Okay, students, we are here. What is the date today? This is Monday, October 15th? Yahoo. Okay, so we just watched a video clip about crumb rubber and the possibilities that it could cause cancer. That's what's listed right before this lecture. So, and that was came out in 2014. So we had a little bit of discussion about it, and they're still doing work on it. They're doing work at Penn State and some other places chemically to actually look at this further. So, and it takes a lot of money. It takes a lot of testing where you can actually eliminate some of the confounding factors, other factors that might, play into it. So we should see some things. There's a sports turf managers meeting down in Arizona in January, and I'm sure they'll be addressing part of that issue again. So just to let you know, because I've seen it in the news again lately about crumb rubber and people looking at that. So we'll just keep up with it and watch the data as it increases, okay, as to what's going on. So the main thing would be to look at the data and be able to analyze it for what it's worth and not to react emotionally, because that's exactly what that TV thing was trying to do, is hit at your heartstrings and say that we're killing everybody, which maybe in the end we do have some problems there. There's something happening, but we don't know what it's related to. And that's all I wanted to bring out, is that they're looking at it, and it's taken at least another 4 years to look at it. So I'm not sure what they're doing in the meantime. I would rather use natural grass. That's my solution, is let's go back to natural turf, because it's a lot easier to replace a natural turf field and cheaper than to put in another plastic thing that doesn't transpire. Okay, off my box. We're going on to fertilizers. Of course, we don't have to fertilize plastic grass. That's one of the things they're selling them on. Okay, but fertilizer is relatively inexpensive compared to a plastic field. Okay, so and I'm going to hand out labels on Wednesday. That's what's all through next week too. You'll do another exercise with actually developing a fertilizer program. But for this week, I just handed out the practicum. What does it have on the label on the top of that one? What does it say? And you'll see Bill Griffith's name is on it, because I just haven't changed it, because I thought it was a really good exercise. So say fertilizer practicum B, or what does it say on the top? Okay, so week 4B. Okay, so I think there's actually one in there in our handout that is exactly the same, that was just called something else, but I'll erase it. So this is what we need to do for this week. Okay, is get through these. So let's make sure we get through the basic of it. Now what I want you to do is maybe try to do the first one, as we go through this, and then look at it over the week, so that we get it down and make sure we get it intact before the weekend, right? Okay. So when we look at fertilizer bag numbers, everything is expressed as percentages. You've got nitrogen, phosphorus, and potassium. And also sometimes there's going to have to be some additional nutrients listed. And if they are listed after this, they're going to have, like, it might say 2S, which means it's 2% sulfur, or 3Fe, so 3% iron. Because sometimes they'll put that, or they might have some other micros in there, but it'll always tell you what the percentage that's in there. Okay, so it is a ratio, and it gives you the amounts of nitrogen, phosphorus, and phosphorus is P2O5. Okay, and I think we talked about that probably the first part of last week, where I said it's actually P2O5. So we actually, when we look at phosphorus, we have to multiply it by a percentage to figure out what's actually phosphorus. And when we look at K2O, okay, one of them is 83%, one of them is 44%, to get to the actual phosphorus and potassium in the amount of the fertilizer.
Did we do that in your ag science? Did we do that? Or didn't we do that in your ag chemistry class?
No, we didn't. We actually talked about it last week. I actually wrote it on the board.
Oh, yeah.
And I'll look at the rest, but we'll make sure that you don't have to do that for this exercise. I think the exercise that we are doing is actually looking at the cost in pound for pound of nitrogen is what's in this exercise. And so then most of the growing, it depends on what you're looking for with the fertilizer, but more often than not, we're trying to grow the leaf tissue and we're probably calculating our nitrogen on the base of our nitrogen source, not on phosphorus or potassium. Okay, so it depends on the time of the year. We're into fall now, so phosphorus and potassium are pretty important for the health of the plant. Phosphorus and potassium for the roots. We don't want to push top growth as much. We want enough to make it healthy, but we don't I can't talk. We don't want a lot of soluble fertilizer. You know, at least over here on the west side, we still got probably another month before we start hardening off, and we've had some pretty heavy frosts here in Walla Walla. Those of you who are in other parts of the country in the southern region, you're probably not anywhere near going to sleep yet. You're doing some overseeding and probably putting out fertilizers to get your ryegrass overseeding to come up. So we've had it was on the news this morning at 5:30 it was 38, but it had been a lot colder because the frost was pretty hard this morning. Okay, so anyway, we're going to try to, this exercise, this practicum 4B, is to get us used to looking at fertilizers and their costs. So we can look at the source of the material, we're going to look at the solubility, and what's the formulation. Okay, and we're going to make a determination what we're going to buy according to the cost as well to fit in our budget. So the source of the material, solubility, so if it's a quick release product, you know, I'm going to have to put out a smaller amount at this time of year if I don't want to push top growth too much. If I have a slow release that's going to, you know, dependent on temperature to release it, then it's not going to release very much, is it, right now? And that would be good because I don't want it to leach out if I get some rainfall or something like that. And I don't want to push the top growth too much. And then what's the formulation like? Is it all one size granule? Okay, or is it one of these less expensive products that I mix in a different phosphorus source that's one size, a potassium source that's another size, and a nitrogen source that's another size? Okay, and that's pretty hard to calibrate. Okay, and I know we talked about, when you weren't here, Tanner, just about, you know, the Scott's formulations. They're more expensive for homeowners, but they got every little prill that they make is homogeneous. So it's all got nitrogen, phosphorus, and potassium in each prill. And they're all the same size, so it's really easy to calibrate. But it costs money to do that. Okay, so you get what you pay for. Okay, there is no free lunch. In turf or in basketball or in football, there is no free lunch. You're going to pay something for it, right? There's going to be a trade-off. And we need to figure out what's going to do the best for us, because even though there's a positive effect, there's probably going to be a negative effect too. All right? Nothing's ever totally positive. In turf grass, we have all these little pieces we have to think about. Okay, what's my budget? How many workers do I have? You know, what's the head of the greens committee going to say if I use this? What are the ladies going to say? You know, you got all these things. And I will include the women, okay. They are pretty vocal, aren't they? Okay, and I hate to say that, but they are. I mean, I got it from the ladies all the time as I was foreman of the ladies' course at Medina. But they didn't know I was a lady. They called me young man all the time. I was wearing a uniform. They couldn't tell what I was, so that was pretty weird. Yeah, that's what I said too. Anyway, so the main thing is it's a trade-off for what's going to fit in our situation. So Calvin could make up a plan with a product that's going to fit his particular course, and then Tanner over here is going to do something totally different because his people want something else. But they're both right and could be worked into a fertility plan. Okay, depending on what your budget is. So that's the beauty of it. You can, as long as you can back up what you're trying to do that will benefit your business and your turf, then that's where we can go. Okay, so when we look at a bag, we're going to look to how much actual nitrogen there is in a bag, so percent in a bag. So if we look at these formulas, well, we should have one. Okay, example. I got a 50-pound bag that's 22% nitrogen in a bag. Okay, it doesn't say a 100-pound bag. If I had a 100-pound bag, then I'd have 22 pounds of nitrogen in a 100-pound bag, right? Because it's a percentage, but I only have 50 pounds, so I only have 11 pounds of nitrogen in the bag. That makes sense, doesn't it? Okay, so we're trying to keep this as easy as possible. Okay, and we're going to apply our rate in pounds times the percent N in the bag to give us the actual nitrogen applied. So, if I'm going to put out 4 pounds per 1,000 square feet application rate times 22% nitrogen in the bag. I can take that 0.22 times 4, right? And I'm putting out 0.88 pounds of nitrogen per 1,000 square feet. That make sense? Okay, pretty straightforward. And everybody thinks about this differently. So if you don't like the way that this is presented, there's still like probably 5 other ways you can calculate it and still be correct. Okay, this is how Bill presented it, and I kind of like the way it's presented, so I stuck with this. And so it says these formulas work for total nitrogen, or we can separate that out into water-soluble nitrogen and water-insoluble nitrogen. So now they don't have to put this on the bag anymore. They used to have to put WSN, water-soluble nitrogen, and water-insoluble nitrogen. What does that mean to you?
Water-insoluble?
Yeah.
It
It
will dissolve at all.
will not dissolve, or it will dissolve slowly. That means your slow release, water-insoluble nitrogen. Water-soluble nitrogen means that it's available immediately, like ammonium sulfate. Okay, so if I looked at some of my polyon, that would be more water-insoluble. You know, my poly-coated, sulfur-coated ureas, those are more water-insoluble. They have a barrier so it doesn't dissolve all at once. Okay, so obviously if I look at this, something with more WIN in it is probably going to be more expensive, isn't it? Because I have to do more manipulation of it and treat that product. Whereas the water-soluble products will be less expensive. Okay, so when you look at a fertilizer bag, you know, just go over to, you know, our local hardware store over here, look at L&G. They've got Wilbur Ellis fertilizer out there for sale right now. Go look at the label. Or I'll take a picture and bring one in. And
Water-soluble is less expensive than water-insoluble?
yes, water-soluble is usually less expensive than water-insoluble.
More of a reason to fertigate that?
What?
Would that be more of a reason to use fertigation?
Would that be a reason? I'm repeating the question for the online kids. Would that be a reason for fertigation? It would be if you had an, how should I say, a very efficient irrigation system. You know, one of the main reasons we don't fertigate is just because our irrigation systems aren't good enough. You're going to see every mistake you make. Okay, you'll see every spot that gets missed. And then what if you have too much overlap? Then you're going to get a lot of fertilizer in one spot and not enough in another. So that's one of the reasons we use a lot of granular products and then water it in. So we know we get an even coatage, is coatage a word? And even, we can use spreadage. How about that? We can make up any word you want there online if you want to, but an even application is what I'm trying to get at. Okay? And we're trying to get the growth rate we want at that time. So I'm not sure if I did that right or not, but we're getting there. It's 3:15 in the afternoon, guys, so the rest of you are probably just getting home. Okay, so let's look at what does it cost for your actual nitrogen. So I think in your homework in that practicum B that you guys need to print out online, does it give you a cost for the bag? So pounds of N in the bag equals the cost to N per pound. So if it's $9 per bag, and I have 11 pounds of nitrogen in the bag, then it is costing me 82 cents per pound because 9 divided by 11 gives you 0.82. So in each one of those examples you have there, you can figure out what it's going to cost you per bag, per pound of nitrogen per bag. So you could compare them. The cost alone is not the only thing you should be considering, is it? Okay, it might be if you don't have any other money and you don't have a choice. Okay, so one of the reasons I could think about this is, you know, I say, well, a water-soluble product is less expensive than a water-insoluble. Okay, if my budget is a key factor, and I've got to get the cheapest thing possible, then I'm going to be putting out very small amounts of water-soluble product more times. So I can still use that water-soluble product, but it's going to cost me more in labor, isn't it, to get it out? If I use a water-insoluble product, I can put more out that releases over a longer period of time, but I don't have to go out for another 6 weeks, or I can wait. So I can use both products, but I'm going to have to balance my labor cost with my cost for the product. Does that make sense? Because we talked about that when you were gone, Tanner, too. Okay, so if I'm looking at how much it costs per pound of nitrogen, that means that it makes sure that I'm comparing apples to apples cost-wise anyway. Okay, what is the cost? But I still have to look at what's the release rate too. What am I getting for that money? Okay, but I can at least look at how much it costs per pound of nitrogen per product and say which one is the cheapest or which one's the most expensive, can't I? Okay, so that gives us a way. Okay, so the other factors we have to look at, like I said, water insoluble or water soluble. What size is the package? Okay, what if it costs me 82 cents per pound for a 50-pound bag, and then if I get a 10-pound bag, they charge me $1.62 per pound of nitrogen because it's a smaller bag. Then you're going to get a bigger bag, aren't you? Isn't that usually what happens? The smaller the quantity, you pay more for it because bulk is usually the cheapest way to get it. So just think about it. And then what's the nitrogen source? We didn't even talk about that yet. We're looking at per pound of nitrogen, but if I haven't considered what the source is, maybe I don't even want that cheap stuff, which in a lot of cases that's what happens. I don't want that. Or maybe you do. Okay, but you need to know the reason why you want it or why you don't want it. And we'll go through that next week too when we hand out fertilizer labels. Okay, so let's look at some conversions. Okay, so if we look at the weight of the bag times the percent N in the bag, so you get 50, so let's just say, I think I have an example after this, don't I? Yeah, here's 50 pounds, that's what we were just working with. We have 22% nitrogen in the bag, and then I'm going to divide it by what the area that the bag will cover. So the label says it'll cover 10,000 square feet. So I have weight of the bag times the percent in the bag over what it'll cover, and that gives me 1.1 pounds of nitrogen per 1,000 square feet when I put it out at the bag, what it tells me to do. Does that make sense? You're looking, Calvin, but you're not. Okay.
Yeah, I'm just looking at the assignment.
Well, don't look at the assignment. Let's get through the notes first. You should be writing these down in your notes and then look at the assignment. Okay, because you're going to get confused because we're not quite to where the assignment is yet. Okay, so we can ask questions about that as we go. We only got a few more slides here, and then we can look at the assignment as well. Okay, and here's a problem. Some fertilizer bags don't list a specific application rate, but how much area the bag is supposed to cover. Okay, so that's what you can do. Some tell you the application rate, but this is the way you can figure out what the application rate is supposed to be. Okay, and there's always going to be exceptions to how I can do this. Okay. I can also look at the desired amount of nitrogen per 1,000 square feet. So what do you want to put out? And we've got an example here, divided by the percent N in the bag, and that can calculate my application rate. That's another way to do it, isn't it? So if I want to put out 1/2 pound of nitrogen per 1,000 square feet, okay, I have 22% nitrogen in the bag. That sounds a lot like ammonium sulfate to me. And so 0.5 divided by 0.22 equals 2.27 pounds per 1,000 square feet for an application rate to get 1/2 pound of nitrogen. Okay, and the magic of that 1/2 pound of nitrogen per 1,000 square feet is that's what research has shown, that we did at WSU over on the west side, that we found that we could put out 1/2 pound of quickly available nitrogen per 1,000 square feet without leaching it in a sandy root zone. Okay, so that's what we calculated. We don't want to put out more than 1/2 pound of quickly available nitrogen per 1,000 square feet so that I don't leach it out of that sandy root zone. So using this formula, using the desired amount of nitrogen per 1,000 square feet divided by the percent N in the bag, it allows you to decide how much N you want to apply, and this gives you management control over the area. Okay, so I could put in 1/4 pound, couldn't I? I could put in, that's pretty, you know, depending on what size your granules are, sometimes you can't calibrate that low. And that's why you might go with a water-soluble product that you're going to spray out. Haven't some of the people where you've worked used a liquid applicator and maybe used a spray hawk or something else to put it out?
Then they get bunker rigs.
Yeah, and a lot of times Yeah, but a lot of times they'll put out some micronutrients with it too. Or they'll do it because they have to put a fungicide out as well. So it all depends on what they're doing. They're going to try to put as many tasks together to limit labor costs as possible, right? Okay, so that's for today. So let us see. I'm going to go back in here. Let's look at the first. Let's see if I can, for you guys at home, let us go and see. Oh, that's not what I want. I'm going back to the assignment, and I can't get there. There, lecture. There's the homework. Okay, so let's just look at the first problem on the homework, and we'll end there today. Oh, why do I get this lady in the bathing suit? I have no idea, guys. Yeah, she's gone now. She's gone. Okay, so let's look at this assignment. So for each one of these, and we kind of did ammonium sulfate already, right? Yeah. It wants you to figure out the amount of N in a bag. And right here, there's the formula for the amount of N in a bag. It wants you, for this product, to figure out the cost of N per pound. I see a formula here, so this is the weight, the one that starts here, this is for A. This second formula here is for B. It says, figure out the application rate using a 1/2 pound of water-soluble nitrogen per 1,000 square feet, which was, didn't we figure that out here? So we could put the desired amount of N divided by the percent in the bag for your application rate. And then using your application rate from C, so using that formula, what is the amount of water-soluble, water-insoluble, and total N per 1,000 square feet when you make that application? And then the last thing you have to do for each one of these situations is describe what you expect to happen with the grass when you put it out. So if I'm putting out a 1/2 pound of quickly available nitrogen per 1,000 square feet, am I going to expect excessive growth? Am I going to expect, moderate growth? I mean, how long is it going to last, depending on what fertility rate I put out? And notice that for ammonium sulfate, it's all water soluble, so you have 0% water insoluble, right? So you don't have to calculate that. All right, but the other ones give you a percent of water soluble and insoluble, so you're going to have to split up how much is available, how much is not available, and what's the growth rate going to be. Does that make sense, what I'm asking you to do? The guys here are sleeping, by the way, guys. I just want to let you know. Are you thinking about it? Okay, so what I would like you to do, I know there's another lecture in here, but what I'd like you to do would be to look at these and just see where you're at. I think what I'll do is I'll close this assignment and I'll try to get back to the second lecture and just see exactly, I can't remember exactly what was in there, so I'm just going to close this down. Oh, there's the lady in the bathing suit again. Sorry. I'm sorry, guys. Okay. Let's go to modules. That was lecture 412A. Beep, 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 beep. We'll find it. Let's see what's in 412B, because that's the second. And I've got some other talks that I want to give you anyway in here, because it's actually phosphorus recommendations. So let's see what's in 412B, because I truly cannot remember right now. And I probably have some more notes for you. Let's just see what's in there if I need to give you some more. Okay, so this looks at each one of the products. Okay, let's see how many slides we have here. So there's only 15 slides on this. So I think what I want to do, because I want to give these guys some more handouts too to take notes on the fertilizer carriers. If you don't mind, I can go ahead and record this and you can put notes on tomorrow if you want to, because I don't have them printed out for you. But let's go ahead, we've got time to finish up this lecture. Let's just look at this, and then I'll print out the notes for you, and you can go back through and make some. Let's just go ahead and get it done for today. Okay, so let's look at the nitrogen carriers. Some of these you're going to recognize. So ammonium nitrate, which we don't use a lot anymore because if we put it with diesel, we can make bombs, so they don't want us to use it. It's 3300. Okay, it's a quick release. Works well in the cold because it's a quick acting. It's not dependent on microorganisms to release it. It's a dry granular. It's acidifying. So if I have a high pH, it's going to help me lower it. Half of the nitrogen is nitrate, half is ammonium. Okay, and we know that plants take up both ammonium and a nitrate, don't we? Okay, and it's left on the surface or incorporated. Okay, usually with turf, you're going to water it in. They use a lot more in crops still. Okay. Oh, and I got them yawning in the seats here, guys. So you guys are probably doing the same thing at home. Okay, ammonium sulfate, 2100. Quick release, acidifying. It doesn't say it up there, but it contains 24% sulfur. So if you want to remember, just think pound for pound. With every pound of nitrogen, I'm putting out a pound of sulfur. Because you got about 21% sulfur, so you're in the range. Okay, just think about that. That's why it does so well here in the Northwest. There's something about the sulfur that helps the nitrogen be more efficient in our soils. It's white or grayish-white crystal. It's left on the surface, watered in. Occasionally it's incorporated. The only time we're going to incorporate it in turf is when we're first establishing it, right? Otherwise we're causing a problem. Okay? And we have really fine formulations that can be dissolved and sprayed as a liquid with other formulations, right? Haven't you seen it? Looks like sugar. The lawn care people use it a lot. Okay, I don't like to use it in hot weather because, boy, I can toast everything, right? Urea. That's probably one of the most common sources of our fertilizer. I think that's the last, yeah. 4600. Okay, first organic molecule to be made in organic chemistry was urea. Okay, 4600. Quick release. One of the highest sources of nitrogen. That's a lot of nitrogen. Okay, so if I don't have some way of making this like a sulfur-coated urea or a poly-coated sulfur-coated urea, I'm going to burn the bejesus out of the grass if I put that out in the middle of summer, aren't I? A full pound. Okay, it can be granulated or prilled. It can be applied as a solution. We've got to get it into the soil solution pretty quickly because this actually will volatilize. One of the fellows I worked with when I worked for the Sugar Corporation basically did research work on urea. He was the first one, Steve Titko. He was doing work at our farm in Angola, Indiana. And he showed that a lot of, if you didn't irrigate it, a lot of it just volatilized and you lost everything you were putting out with some of our lawn care applications, which is hence why we went as far as poly-coating things and actually making sure that the customers watered it in right after application. So usually a 1/4 inch of moisture is enough to get it off the surface so UV light's not breaking it down. And that was probably done in 1982. Were you even alive? Yeah. Okay, so you got to realize Gwen's at the beginning of the industry, although I feel like, you know, there were a lot of years before me that people were putting this together. All right, so we get into some of our more water insoluble, slow release. Isobutyl diuretic acid, okay, 3100. 27% water insoluble. Okay, so that means it's 4% water soluble. Okay, IBDU is one of the first sources we used in Florida. Isobutylidine diurea. Okay, it's released by water. Okay, so when I have really small prills, it releases pretty quickly. If I'm doing roadsides, I make a big prill and it doesn't break down as quickly because when it waters, it only so much disintegrates, right? So it's not dependent on temperature. This is one of the, for those of you in the southern region, that's why we use this a lot in Florida when I taught down there, because I could get it to release at a very even rate. It didn't depend on temperature. I just had to water it and it would release. Okay, very resistant to leaching and no atmospheric loss. It's got a very low salt index, the lowest of all commonly used nitrogen sources. Okay, but it costs. Okay, yeah. It's more expensive. Okay, but we aren't looking at that right now, are we? We're looking at what's the makeup of the fertilizer, so you can balance the cost with what you're going to get from it. Okay, so just look at what it is first, and then we'll put the cost in it together.
Generally, you would want a low salt index over a high salt index in general?
In general, it depends on what I'm looking at. I use ammonium sulfate all the time. But if I kept using it all the time, that means I'd drive my pH pretty low, and I could have problems. Okay, but if you look at the total overall process in the environment, if the plant's taking it up and I got enough irrigation, I'm only putting it out in small amounts, am I really affecting that much? Probably not.
Right on.
Okay, and people say, oh, you put out an acidifying, you're killing all the microbes. Well, that'll probably change in about 3 days, okay, depending on the amount. So it's relative, okay, as to how, I'm not saying it doesn't change the balance, but it's not going to kill everything in the turf. There's so much going on in the, if you look at that, Honey, I Shrunk My Kids, and you think about turf in that aspect, all the stuff that's going on in the turf environment, there's so much for us to think about. We only know 1% of the 10,000 microbes that are in there. Okay, I don't know what's going on, but there's something happening in the soil. Okay, we look at some of the things we add back, like compost tea and things like that. I just want to know what I'm putting back, so I know how am I changing the balance. What am I actually doing to benefit? Okay, so that's what I want to do. I didn't realize I'd gone on to that. Okay, I think we've only got a couple more. Oops, sorry. Okay, so we have urea formaldehyde, which is almost like plastic. Okay, so when we use this in the Midwest, and on the west side of Washington, this came in a blue formulation. It released in July, and that was the only time. And it's 20% water, 27% water insoluble, 10% water soluble. And then our methylene urea is similar to the urea formaldehyde, but it's got a quicker release rate. It's only 12% water insoluble. And what makes that nice to work with is that the methylene ureas are the ones that the longer the chain, the slower the release. So if I have a really long chain, it's slow release. I can go moderate and get a moderate release. I can go short and get a short release. So this is what gave us the polyions and all the other things. This is what helped us have different release rates. So we could plan on that. But obviously, when I have this flexibility, that's going to cost me some money too, isn't it? Because I'm processing it. Okay, it means there's more chemistry involved. Okay, now we've got sulfur-coated urea. Sulfur-coated urea came out the year I graduated from college. Right after that, 1978. Look how old I am, okay? Because
You're much wiser now.
well, with sulfur-coated urea, all you had was urea coated with sulfur. Okay, so that was slow release. Well, I'll tell you what happened in Medina. They went out, they fertilized with it. Okay, somebody went out to the big old monster out there and fertilized it. Somebody forgot to turn on the irrigation. Okay? Somebody mowed fairways.
Oh, shoot.
Somebody broke all the sulfur capsules with no irrigation. Guess what happened to the grass? It burned. We lost 3 fairways. We had to bring out the fellow from Purdue. It was just Medina. But we had to, so this is a brand new product. But that's what we figured out is Jesse didn't get around and get the irrigation turned on. So the problem is those capsules were then, once that sulfur coating was broken, it was quick released and we burned the crap out of those 3 holes.
Did Jesse keep his job?
Oh, Jesse kept his job. Yeah, but my boss did not. And it ended up that was a big problem later on. Well, the buck stops somewhere, and it's just like, it has to stop with somebody. But there were that was not the only reason. Politics was the big reason. And it's just like, when you're doing a good job, the basketball coach keeps his job, right? Even if you're doing a good job, sometimes you don't keep your job, and that's the way I looked at it. Chicago area is very political, which, that happens everywhere, right? Just depends on what politics are going on. Okay, so that's just an example. That's where the poly coating came from after that. So that sulfur coating wasn't enough, but so that was pretty That was pretty amazing that happened. And then at that point too, we always had Milorganite comes out of Milwaukee, Wisconsin. Okay, Milorganite always sponsored a big fertilizer convention at Medina Country Club. So we were using that on green, 620. What do you see about that? It's slow release. It's activated sewage sludge, meaning it comes out of our sewers and we just process it. Okay, look at how much nitrogen there is in there. A lot lower percentage, isn't there? Okay, what else do you see? What's the second number? Nitrogen. What comes after? Phosphorus. Okay. Yeah, and then anything that comes out of a living thing is going to have phosphorus in it. Okay, so if I have an organic fertilizer and there's no phosphorus in it, it's been manipulated to get the phosphorus out of it. Is that still organic? Well, you say no, but some people might tell you yes. But it's still manipulated, isn't it? It's not truly natural. Because there's no way I can have a living thing is always going to excrete phosphorus because I need it for energy and some of it's going to go out when I'm breaking things down. Yeah, it's just going to happen. Okay? So we did a lot of work, and that's what I'll show you tomorrow. Or not tomorrow, Wednesday. We'll go over a research project that Dr. Eric Miltner, who's now with Koch International, we did a project where he looked, and his graduate student looked at how long does it take for you to catch up with an organic product, which is based on microorganism release, and soil temperature. How long does it take for that to catch up with a synthetic product before they look the same? And basically, what you'll see is it took 2 years, and then it was the same. Okay, but you had to do something to supplement it in between so that the turf looked acceptable. And it depends on your climate too, doesn't it? Okay, so all of these, if I had this, I'm not going to put that out in the late fall because it's not going to break down. And I could, and if it does, if I put it on a frozen soil, I could leach it right off the surface, couldn't I? But spring might be a really good time to use it. So for all of these, summer would work because it would release. Yes, it would, because the organisms are growing pretty quickly. Okay, but it smells too. Okay, some of these organic products can smell pretty crappy. No pun intended. Sorry, guys, online. But it's a slow release product. Okay, we also have some phosphorus carriers we're going to look at here. You've got both MAP and DAP, monoammonium and diammonium. Phosphate, 1148-0, 2050-0. Monoammonium is used in a lot of fertilizer sources. It's only 11% water soluble. When we look at the diammonium phosphate, it's used in a lot of liquid fertilizers too because it has a higher nitrogen percentage, so then I don't have to put as much nitrogen in. Oh, I thought I had another slide there. Okay, but again, with some of those, if I have a higher water solubility with that nitrogen source, there could be a little bit of burn with that. I need to watch it. They need to be irrigated in. Superphosphate is used in a lot of our granular fertilizers, 020-0. It has both calcium and sulfur in it. Treble superphosphate is 045-0. It has calcium and sulfur in it as well. I'm going pretty quick through this, okay? Potassium carriers. We have two. Potassium chloride, or muriate. I think it's M-U-R-I-A-T, muriate of potash, 0060. This is the most common potassium source, KCl, but it has a high burn potential. Okay, so it's quickly available. You need to irrigate it in. They actually, and I don't know whether this is available or not, they're working on a polycoated source of potassium chloride to make it have a lower burn potential. And then potassium sulfate, 0050. This is what I like to work with. It's got a lower burn potential, but it's more expensive. So they're not going to put it in a fertilizer if it's more expensive. Okay, or you'll pay for it, right? But it has a high acidifying effect as well. It does have sulfur in it, which is why I like it. But, if you've got a lower pH, maybe that's not what you want. Okay, so each one of these you can see pluses and minuses, can't you? So I'm not promoting one over the other. I'm saying there's a balance here. And in different situations, I might pick something else. Now, I didn't give you any costs on these things either, but you can look at some of these as we go through. Okay, potassium carriers, potassium nitrate, great fertilizer, 13044, but it can have some burn potential, but it works really well. It has to be irrigated in. 13% nitrogen, quickly available. Ferrous sulfate. I don't see any nitrogen, phosphorus, or potassium, do you? That's because it doesn't have it. It's all iron, right? 20% iron. So we usually add this in as an additive to our NP and K, don't we? So you'll see 20% Fe or 8% Fe on the label. Ferrous ammonium sulfate contains 18% sulfur. We use this a lot for moss control. Okay, if we get it too heavy, the grass turns black. Okay, it leaves nice black footprints. Be careful. Foliar applied, so I don't want to get the rate too high. I can burn with that. It usually just burns the moss back so the turf will grow up over it. And basically the moss gets shaded out. Doesn't totally control it. So there's your ferrous ammonium sulfate. If we look back, that was ferrous sulfate has 20% iron, 18% sulfur. Ferrous ammonium sulfate has 7% nitrogen, because I said ammonium, right? 14% iron, 15% sulfur, 7%. Whoops, I didn't spell that right, did I? Nitrogen. Okay, should be nitrogen, and it's foliar applied. So I get more bang for my buck out of ferrous ammonium if I want the grass to be growing. Chelated iron, 7% nitrogen, longer residual response. With a low pH, or excuse me, with a higher pH, iron gets tied up. It becomes unavailable. That's why we get chlorotic plants. It can't take up the iron, so you get green veins and yellow leaves because of the iron getting tied up. Calcium nitrate, 20%, contains, I already said that, slight pH raising effect, not much, but it's more than acidifying. Nitroform blue, the 3800, again, very slow release, 27% water insoluble. It's a sprayable powder. So this, you'll see a lot of lawn care companies using this because it's a sprayable slow release.
Don't you kind of want to stay away from powder type of,
Not if you've got an agitation system and you're pumping it, it doesn't matter. You just can't leave it in the tank overnight.
Control don't even bother. Like, don't even mess with it. It just doesn't apply very well, and it's pretty dangerous.
Nitroform blue? Who told you that?
He said just in general, powder solvents or sprayable powders or something like that.
Wettable powders can be a problem, but they've applied them for years. It all depends. They've got better formulations.
Yeah.
So I'm just trying to give you options here. It comes in granular too, so you can put it out as a granular and just. But there's some places where they can't apply it granularly and they have to apply it as a powder, or basically they've already got this into suspension in a container now, and that goes into the tank instead of just putting the wettable powder in. That's what they've changed in a lot of cases. So the way that it's formulated is different. So yeah, I agree with you. Wettable powders are a pain in the neck. But you can also, other things that you can put out with your fertilizer, root enhancers. You've got all kinds of things people are going to sell you, but you need to make sure you've got a good balanced fertility program first and then add in additives. Does that make sense? So you always want a balanced system. Soil enhancers, penetrating agents, wetting agents, surfactants. Did you learn about those in pesticide applications and stuff? So you've got things, microbes. People will sell you anything, right? So you want to look at the data and see what they say and what it's going to cost and what will it do for you.
Where the microbes do like try and...
Microorganisms.
Yeah.
So they're thinking that they can apply them and they're going to benefit the turf and it's going to grow like, just, yeah. But how do you know what you're putting in? If they don't tell you what it is, I have a very strong opinion about paying money for it. Because how do I know it's going to change the balance in a way that I want it to?
Right. No, I was thinking that like microorganisms.
Oops, that's the end.
You apply it to turf to eliminate some other microorganisms.
Well, but how do you know? Here's the thing. If we only know 10% of what's even in there, how do we know what we're doing? I just gave a talk on biological disease control to the Inland Empire. And basically there were 6 biocontrol agents, and none of them work real well.
Yeah.
Okay, none of them work well enough for somebody to say, I'm going to have a high quality green if I use this instead of a fungicide to control disease. I can always keep the plant healthy and use this to prevent it and not make as many applications, but it's never going to be a high quality green.
Yeah, and the only reason I asked is we saw a video of,
Tyler's?
not Tyler, I think it was Bill's class, of superintendents that are applying some kind of microorganism to.
Bill who?
Bill Griffith.
I think that was Tyler's class. I remember that.
Yeah, you think it was?
I don't think it was Bill Griffiths because it would have been this class.
Really good back.
And unless you saw.
He like applies like some like nematodes.
Right.
Oh, well, you saw a video in my class of applying nematodes.
Oh,
Yeah.
okay.
Beneficial, entomopathogenic nematodes, so they're beneficials.
Yeah.
But those aren't
That's why I
microbes.
asked,
Yeah.
Like, is that a microbe or what?
No,
how do you
it's
know?
actually a little insect.
Just trying to connect dots here, Gwen.
Okay,
You know,
well then
make
that's
connections
good.
In my brain.
That's good. He's connecting the dots, and that's what you're supposed to do, is connect all the puzzle pieces.
Right.
Okay, so that's an actual living organism. So I can call that a biological control. If it's not alive, I should be calling it a biopesticide or a biofertilizer because it's a non-living organism. So there's so many things, and this is what I found out when I went and gave the talk over in Idaho, is that I didn't get pesticide credit for talking about biocontrol because they will only give pesticide credits for talking about pesticides. So even though I'm trying to limit pesticides, because I put biological in my title, I didn't get credit for it. So that means you need to think about it because pretty much we're trying to balance the pressures that we're getting for both government and local populations as far as how we're doing this. So we just have to think about how can we talk about this and be intelligent in balancing our practices. And it still goes back to integrated pest management, doesn't it? We've done that for a long time, and that's what we're still doing, is trying to balance our applications so that we can have a good enough surface for our people to play the sport, right, and not endanger other people. I mean, we're still thinking about that the whole time we're making these applications. People think we're just doing it willy-nilly, but it's a business. If I don't think about what it costs me to put it out, what I'm using, what my labor cost is, what I'm paying for equipment, what I'm paying for everything else, I could be 3 sheets to the wind.
Like
And
you really want to invest in like a nursery whole, or just in general, like a nursery green, obviously, but I mean.
most courses have a nursery green just so they can replace anything. Yeah.
Yeah, and then like I guess like a fairway type of, or something that resembles.
I'm going to turn this off.
Fairway thing.
A lot of the golf courses do that. On the west side, everybody has an experimental green and places. So in case something